Yes, guys, this will be the last video. This question, it's like 30 max in total. So all I'm gonna say is be careful of analytical geometry. It's an easy way to get marks, but if you underestimate it, you can easily lose a lot of marks. Yeah, I have my little bed with me next to me, so hey, it's feeling a bit cold, but yeah. So 3.1. It defines it as defining collinear points. Collinear points are points that lies on the same straight line. So if I have a straight line, this is my straight line. Let me draw another straight line. Maybe different color, this one. Okay, cool. So, and I have point A, I have B. No, what am I doing? I have point B, I have point, I'll go purple, I have C, I have point D, I have point E. Realize that point A, A, E, and B, they are collinear, and D, E, and C, they are collinear. You see, so the reason this 3 points are collinear is because they're on the same straight line, which is this purple straight line, and the reason these are collinear is because they're on the same straight line. Do you know what I mean? For real. So yeah, so this guy, they are saying that we have this point ABC. A is let me draw my Cartesian plane and some points in there, right? So yeah, so we have this point A, which is -8 and 0. I think it's gonna be somewhere here, A, and then I don't know what B is gonna be and C, but for C I can guess, since it's -14, probably, I don't know, I'm just guessing this is X and -14. I'm just like, it could be like on this side, it could be like minus oh, I don't know, but let's just leave it like this. And they say -8, then we have X -5, and we have -8. So say this is -8, this is -14, and our straight line then will be something like this, right? And this is the point. So yeah, man, they say, yeah. So the question is, how are you gonna solve this question, né? How are you gonna solve this question? So let's get started. -8, damn. -8 and 0. I have that one, I have that one. So the thing is, ABC, ne? So my thinking with this question is the gradient of AB must be the same as the gradient of BC. Ne? So I'm gonna do that for AB, changing Y over changing X, changing Y over changing X, changing Y over changing X. Yeah, what do we have? Y1 minus Y2, so 8, that is Y. No, 8, that is Y. B, this is B. B, that is 2. So Y, I can say 0 minus 8. And then I will say -8 minus, then we have X -5. Ne? That is my gradient from AB. And then it has to be the same as this one here. So I have -8 minus -14. Then I have X -5 minus X. Then from here, I'm just solving for X. If I do no mistakes, trust me, you're going to get the right answer. So you have 8, negative and negative, positive. So you have -8 this side, plus 5 minus x. On this side you have minus 8 plus 14. This side you have x. Yeah, x. Okay, cool. Since I have, look at this, I have x, I have minus x, so I can just write no x and just write minus 5, ne? And yeah, then I have 8. I have 8 all over minus 3 minus x. I have, that is gonna be 6 over, yeah. So maybe let me put this minus here. Then I cross multiply. I have 8, I think that's 40. So I have minus 40, which will be minus 18 minus 6x, right? So I transpose the 6x, I have positive 6x. I transpose the 40, I have 40 minus 18 x, 6x. 40 minus 18, probably 22. 40 minus 18, 22, divided by 6. Therefore x is equals to 11 over 3. Damn! 11 over 3. So 11 over 3 is the point, is the x value that's going to make point A and B and C to be collinear. We're done. You have your 5 marks. Let's move on. Let us move on. Cool. So now it's an interesting one. You have your Cartesian plane there, your triangle, ABC, the points are given. You know, it's a triangle. They say point D and E, our x-intercept. X-intercept, remember, y is equals to 0. So x-intercept, you have y equals to 0. So yeah, and then AC, let me see, AC, this is AC, this is AC, and AB. Yeah, they're just telling the x-intercepts for the lines, yeah, respectively. So study diagram below and answer the questions that follows. Cool. Let us do that, ne? Remember, we now have 5 marks. So we have 5 over 30. There's 25 marks left. So let's get on it, ne? The first question, it says calculate the coordinates of M. Where is M? Okay, it's not in the diagram, but they say M is the midpoint of BC. So where is BC? BC, here is BC. So M is gonna lie somewhere here. Yeah, M is gonna lie somewhere there. So we can say we'll say 1 midpoint of BC, x, y. It's gonna be x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now I'm substituting, and when I do that, I have 6 plus 0 divided by 2. I have minus 2 minus 6 divided by 2, and the answer will be 6 over 2 minus 8 over 2. That is 3 minus 4. So, damn. I don't know what's. Yeah, cool. So we have that will be 3 and 4. So this point right here, it's 3 and minus 4, which kind of makes sense in terms of the y value. It's between minus 2 and 6, minus 6. So yeah, we have the coordinates of M. This is M. Next question, calculate the length of AC. AC, and leave your answer in its simplest set form. AC, I'm just gonna write the coordinates here. For A, that's 210, 2 and 10. These are coordinates of A. So, and AC, C coordinate, that is 0 and minus 6. So number 2, if I calculate, what do we call that? The distance So distance of AC will be the formula first, y1 minus y2 squared plus x1 minus x2 squared. The answer is gonna be y. So I have, okay, let me say minus 6 minus 0 squared plus I have 0 minus 2. No, damn, that's not 0, that's 10. So it's minus 6 minus 10, yes. And then it's 0 minus 2. Cool. Squared. I can go straight into the calculator because this is just 2 marks. Yeah, well, this is just 2 marks, so you don't need plenty of work. Minus 6 minus 10 squared. Let me see. Oh, yeah. What am I? Oh, squared. Plus 4. Yeah. So if I say plus 4, leaving it in the simplest set form, that is 2 square root of 65. Right. That 4 is coming from minus 2 squared. Yeah, 4, and then let me see. That is 16 squared. Damn. Yeah. Cool. Let's go. Let's move on. Number 3. Write down the coordinates of F. Ne? If they say if A here is A here. Where is B? Where is B? A, B, C. Maybe I'll put F somewhere here. F. And then yeah, I go on. I go on, extend to F. Nah, but if that's the case, F will have to be somewhere here. So then I have ba. Then I have ba. And then there you have it. So they say write the coordinates of what? Write the coordinates of F. If ABCF is what? Is your parallelogram. Now the question is, what is a parallelogram? You see, it's very important to remember these things. What is a parallelogram? Parallelogram is that pushed rectangle. It's a rectangle and then it was pushed a little bit. So now, yeah. So you have to remember, you have to now remember like something nice. So for me, one thing that I know for a parallelogram is that I can have, here's my straight line, right? And this is a midpoint. This is my midpoint. Ne? I know that this line is equals to this line. This line is equals to this line. So it implies that this, let me say K. Point K is what? Point K is the midpoint of O. So probably there's a short way of getting the answer. Right. I think there is a short way of getting the answer, but I don't know. So my mind is telling me, first I'm gonna find the midpoint. I'm gonna find K. After finding K, I'm gonna use B and K to find F. Let's go. So midpoint here, AC. Midpoint here, AC. Don't have space. Yeah, I don't have space. So number 3, I'm gonna find the midpoint of what? Midpoint of AC, I believe. AC 210 0 minus 6. Midpoint of AC, which is gonna be so x1 plus x2, y1 plus y2. So then that is okay, I think I have x being 2 and I have x being 0, so it's gonna be something like this. Let me check. 2 and 0. Then I have 10 and minus 6. So then I have minus 6 plus 10 divided by 2. Then I have what? I have 2 over 2, which is 1, and I have 4, which is 2, right? So these are the midpoints, ne? Midpoints of what? Of AC, and that midpoint is what? Is K. Yeah, so K, my coordinates for K is 1 and 2. Now, I'm gonna use that to say midpoint of F, what? FB. Yeah, FB. Oh, let me say BF, best friend. Okay, so nah, FB is fine. Okay, cool. So here it's X, Y, then it's gonna be like X 1 plus X 2 over 2, Y1 plus Y2 over 2. So yeah, this is how it's gonna be for K. And of course those coordinates, it's 1 and 2. Nah, it's 1 and 2. So now say F is point 1. Damn. Let me take this. Yeah, so say F is 0.1 and B is point 2. So if that is the case, I can say 1 is gonna be what? 1 is gonna be X1 plus X2. X2 comes from B, which is 6. 6 divided by 2. And now I'm solving for X1, right? So this is over 1, of course. Then I have 2 over X1 plus 6. Then X1 is gonna be 2 minus 6, which is minus 4. Yeah. And then for 2, for y values is gonna be, this is equals to y1 plus y2 over 2. Y2 is minus 2, I believe, minus 2. So I'm gonna have this minus 2. So cross multiply, I have 4. Yeah, I have 4 is equals to y1 minus 2, and then I transpose y1, that is 4 plus 2 y1, that is 6. So therefore point F will be minus 4 and 6. Let's see if that kind of makes sense. Let's go to our diagram. We have minus 4 as the X, 6 as the Y. Kind of makes sense though for me. I mean, this is on the negative, here is 10. So yeah, it makes sense. We have the point of F, and they say show that ABCF is not a rectangle, ne? Yeah, so they say show that ABCF is not a rectangle. So we have to do one of the two. We can maybe show that the lines, opposite lines, are not oh, okay, no, I have, remember, there are multiple ways you can focus on a particular characteristics. Here I'm thinking I was gonna say opposite sides you calculate to see if they are equal in size, but then I realized that's gonna take long, like calculating all of that. One thing you can do is you can take two adjacent sides, ne? And those two adjacent sides, you calculate the gradient of each one of them, and you will see that you multiply those gradients and they will not give you one. I mean, I can already see it cannot, this quadrilateral I have here, it cannot be a rectangle, ne? maybe a parallelogram but not a rectangle. Yeah, so let's do that. So I'm gonna take FC and BC. I'm gonna take FC, F. So that is F. Okay, this is question number 4. So I have point F there, my C. Point C is 0 and minus 6. And then point B, what is B? B, I believe, okay. B is 6 minus 2, 6. 6 minus 2. So I'm going to calculate the gradient. So calculate M for FC, which is going to be, I can say 6. Let me say minus 6 minus 6. 0 minus minus 4. That is minus 12 over 4. That is minus 3. Ne? And then I calculate the gradient of BC. The gradient of BC is gonna be what? It's gonna be minus 6 minus minus 2, and then minus 6 minus minus 2, 0 minus 6. That is minus 6 plus 2, minus 6. That is minus minus 4 over minus 6, which is what? Which is 2 over 3, right? And from this I can already tell that this will not be, so I can say MFC multiplied by MBC is equals to minus 3 multiplied by 2 over 3, which is minus 2, which is not equals to minus 1, right? And therefore wawana sochu since adjacent sides not perpendicular, A, B, C, F is not a rectangle. Yeah, I say rectangle, it's not a rectangle because but remember there are many there are many characteristics you can focus on. Remember rectangle, if I draw one for myself, you have a 90 degrees here. That's what I'm saying. So if this is A, B, C, F, ne? BC, this line, this line right here and this line right here, they must be perpendicular, right? And that's what I showed to say they're not perpendicular, and therefore it cannot be a rectangle. We must have a 90 degrees there. You can focus on the lines, opposite sides being parallel, and you can focus on opposite sides being equal, whichever makes sense to you. Or you can focus on the diagonals being equal. Ooh, that would have been like a nice one also. Right, that would have been a nice one. You calculate the diagonals. The diagonals of the rectangles are equal. So you have all the coordinates. Yours is just to calculate the length of BC and the length of AC. If they are not equal, which I believe they are not equal, looking at the diagram, then you will say therefore it's not a rectangle. So man, try to know your quadrilaterals. 5, it says determine the equation of a straight line A, B, and AC. Cool. So I'm gonna do this, ne? I need this diagram, man. So I'm gonna draw on top of it and copy it, ne? Yeah, because I need it. Yeah, there's a rough sketch of, so let me see. The question says I have to find AB and AC, AB, AC, AB, AC. That's number 5. AB and AC. I have to find the what? I have to find the equations. Yeah, I have to find the equations. So let me start with AB. I can say remember, okay, in this example, I don't have my gradient. Probably I did calculate the gradients. But yeah, say I don't have a gradient, so I can use that formula. Y1 over x minus x1. And then here, it's going to be y2 minus y1 all over x2 minus x1. Using that formula, I substitute y minus, so this is AB. What the hell, bro? Shit. Sorry for that. What happened? Damn. So that is a damn. Yeah, no. Okay, yeah, so I substitute point A, which is my point 1, that is 10 minus 10 x minus 2. Then here I have minus 2 minus 10. I have 6 minus 2. Continue with the math. I have y x minus 2, that is minus 12, and that is 4, that is gonna be minus 3, and y minus 10, x minus 2, and then I multiply, cross multiplication in y minus 10, that is minus 3 x plus 6. Y is equals to minus 3 x plus 6 plus 10, and that is gonna be minus 3x plus 16. Let me see, it kind of makes sense. So yeah, that is AB. And then for AC, yeah, for AC I will do this sort of the same. Yeah, I'm just making some space. So for AC, I'm gonna do this very same thing here. Y minus y1, x minus x1, y2 minus y1, x2 minus x1. Now I substitute. I have y minus 10, I have y minus 2, I have minus 6 minus 10, I have 0 minus 2, that is y minus 10, y minus 2, that is minus 16 minus 2, y minus 10, almost done, that is 8. And now cross multiplication, 10, 16, then 8, cool. Cross multiplication, I have y minus 10, I have 8. Shit, this should be x, man, I'm sorry for that. This should be x, so that means I have x minus 16, then y is equals to 8, x minus 16 plus 10, that is 8x minus 6. Let me see. AC. Yes, that makes perfect sense. It makes perfect sense. So yeah, I have, this is AC, this is AB. Nah. Now they say hence or otherwise calculate the size of angle A. Damn. So let's look at the diagram. So now I'm calculating angle A. Yeah, okay. So now they're just talking about, I'm gonna remove these other points. Yeah, the thing that I drew here. So we're finding angle A, this angle right here. Ne? And the question is how we're going to do that. I'm sure you can see this is a 6 marks question. So there's some heavy work that is needed for this question. There's some heavy work that is needed. Yeah, let's have ideas. Let's exchange ideas. What do you think? What do you think we're going to do here right here? Huh? Cool. Yeah, I just want to give you some seconds, just a couple of seconds, to look at the diagram. Try to think, how are we going to find that angle A? So it's gonna be some yeah, it's gonna be like it's gonna be a nice one. Let me give you some clues, ne? So you have an angle right here, theta, and you have an angle right here, beta, and then what's up? Yeah, man. So these are the clues that I'm giving you. So yeah, I think one thing that can maybe complicate the question for most people will be majority, maybe some people will focus on triangle ACB, whereas this whole problem, let me erase this part, this whole problem, it becomes very, very easy, ne? The moment you focus on triangle ADE, right? The moment you focus on that triangle, it becomes very easy. Look, ne? One thing I think I said this on the previous video, I was saying, always ask yourself a question. Why did these people ask me the previous questions? So if you look at the previous questions, a lot of them, they can help you with the questions you are currently solving. So this question, let's look at 3.2.5. It says calculate the equations of a straight line for AB. Here is AB. When calculating the equation of a straight line, I'm gonna find my gradient, and my gradient is gonna help me get the angle of inclination. So I can say gradient of AB is equals to tan beta, right? And I have my angle, and then they say calculate the equation of a straight line of AC. So then I can say the gradient of AC is equals to tan theta, right? And of course, in this case, the angle that you're looking for is 180 minus beta. That is the angle that we're going to use to get the angle A. So let's get started, ne? You see now that 6 marks is no longer threatening. Yeah, yeah, I'm gonna have to erase the spots. Let's get started. So yeah, let me start. So 3.2.6, the gradient of AC is equals to tan theta. Let me see what was the equation for AC. AC, it was 8, ne? So the gradient is 8. So then I'm gonna say 8 is equals to tan theta, and therefore theta is gonna be tan minus 1, 8. And then I go here, oh no, shift tan 8, 82. I'm gonna round it to 1 decimal place. So it's 82.9 degrees. Yeah. So theta is 82.9 degrees. Now I go again. I'm like the gradient of BC is equals to tan beta, right? And the gradient I believe is -3. So I come here. I'm like -3 is equals to -3 is equals to tan yebo, and then beta is gonna be beta is gonna be so I go here tan -3 -1. Okay, so shift shift tan -3. Right, the angle I'm getting -71.6. I'm getting -71.6, right? Yeah, so now it's a tricky question. This is where now I ask you a question. Try to think about this. Remember, for I think on my examples for angle of inclination, I didn't do an example that had where we had a negative angle. So now this is where your trigonometric knowledge is gonna be very helpful in terms of dealing with that negative value. Like, how do you think we deal with it? I know you know the answer, but just think about why and how. Cool. Now that you have thought about it, so the how we deal with these negative angles, right? You're just gonna do what? So your beta, it's gonna be your negative angle, which is -71.6, and we're gonna add 180 degrees, to get the equivalent of so let me say, and then AC. So 180 -71.6. Damn, I meant to say 180. So I am getting 108.4 degrees, Yeah. So I mean, like, just go back to trigonometry. Go back to my videos and check trigonometric and negative angles just to see how we dealt with them. But yeah, you have your angle, but remember, we don't want beta. The angle that we're going to use is exactly like that, -71. Yeah, because we have okay, let me say, therefore angle AED. Cool. So here I can say, therefore angle AED is equals to 180 -108.4 degrees, and which is gonna be 71.6 degrees. So now I have my angles. Now I have my angles on this side. I'm just gonna do the calculation and say angle A plus angle AED plus I don't have enough space, so I'm gonna make some space here, man. I'm gonna make some space here. 82.9. 82.9. Cool. So I'm gonna say angle A plus angle AED plus angle ADE is equals to 180 degrees. And the reason for this, right, angles of a triangle, Now I am substituting, so A plus 71.6 degrees plus 82.9 degrees, 180, right? And yeah, this is just gonna be A 180 minus 82.9 minus 71.6, and I have the answer, right? So 180 minus 82.9 minus 71.6, it's 25.5 degrees. That means, yeah, this angle A is 25.5 degrees. Ne? Cool. And then the next question is like calculate the area of triangle ADE. ADE. Ne? So first thing, I have to have my base. Area of a triangle have base times perpendicular height. So I'm gonna find my base, which is my base here is DE, and yeah, and what you call this, my base is DE, and my perpendicular height is gonna be this line right here. Yeah, cool. Let me start working. Yeah, this line right here. So this line, the height is gonna be, I believe it's gonna be 10. Yeah, the height is gonna be 10 here. So let's start working on this one. I'm gonna erase everything I have here, and then yeah, we cook. Yeah, so I also need the equations of AC and AE, so I'm gonna go and copy them, ne? Yeah, I'm gonna copy them. uh yeah, so this, the negative one, is gonna be AB. This is AB, and this is BC. No, this is AC. Yeah, this is AC. So these equations, they're gonna help me find my points, like point D and point E, ne? So I'm using AB to find point A, point E, and D, both x-intercept. That means y is equals to 0. So yeah, this one is gonna help me find point E. This one is gonna help me find point D. So let's get down with it. So for point E, 0 is equals to minus 3x plus 16. Yeah, damn, let me see. Yeah, 16 and then 6. Yeah, so plus 16. I go that side, transpose, that is 16, 3x, divide, divide, then x is equals to, yeah man, let's leave it like that, 16 over 3. Let's leave it like that, and therefore D, no, therefore E is equals to 16 over 3 and 0. And then if I go for point D, we have 0, 8x minus 6 transpose 6, 8x, and then x we divide by 8 both sides, over 8 over 8, which is just 3 over 4. So that means therefore d is what? D is 3 over 4 and 0. So my base is DE. So I'm gonna find the distance between these two, right, by saying distance of DE. Distance for DE is gonna be square root of 0 minus 0 squared plus 16 over 3 minus 3 over 4 squared. I put that in a calculator. Then I get 16 over 3 minus 3 over 4. Then I square the whole thing. Then I'm getting what? I'm getting 4.8. Yeah, 4.58. So 4.58. That is D. And remember my height. My height, perpendicular height, is what? Is equals to 10. So from this I can just say therefore area is gonna be, area of that triangle is gonna be half base, which is what? Half base, which is 458. Guys, write the formula here. I'm just running out of space. Yeah, so just write the formula before you do the substitution, then multiply by 10, and then the answer is gonna be 0.5 times 4.58 times 10, then 22.9. Okay, yeah, we're done. So now you have the area of that triangle, and this is the end of analytical geometry. Thank you so much, guys. All the best with analytical geometry, and looking forward to the next chapter that we're gonna do. So all the best, good luck.